Each year, thousands of wildland fire ignitions occur throughout the United States. Each of these fire starts must be managed to meet identified resource management objectives. In order to select the proper fire management option, we must have a thorough knowledge of wildland fire behavior. When an ignition occurs, it has the potential to grow into a major wildland fire, depending on the existing environmental conditions. It may have dramatic effects on resource values, appearance, and public opinion. What unleashes this powerful force of change? Well, it begins simply enough. Perhaps a carelessly thrown match, an unattended campfire, or a thunderstorm. Then before long, a rapidly growing wildland fire, which requires extensive management. Yet every wildland fire that starts like this doesn't become a big fire because firefighters like you may intervene and stop it. Firefighters who know how a wildland fire behaves. In order to manage fire, you must learn the characteristics of fire and the factors that influence fire spread. The more you know about wildland fire behavior, the more likely you are to select the appropriate fire management strategy, which provides for safety while meeting resource management objectives. Fire begins with ignition. The match is the most common ignition device. Friction creates sufficient heat to ignite the phosphorus. Combustion occurs, the match flames. The three most important ingredients required for combustion are heat, oxygen, and fuel. Heat, oxygen, and fuel complete the fire triangle and are necessary components to create fire. If any of these are missing, there can be no fire. In this demonstration, we have all of the ingredients necessary for combustion: heat from the match, oxygen from the air, and fuel in the candle. But remove one of these ingredients, in this case oxygen, and the fire goes out. The same principle is used in managing wildland fires. We control such fires by removing heat, by removing oxygen, by removing fuel. In wildland fires, heat sufficient to cause combustion is transferred to new sources of fuel in three different ways: by conduction, by convection, and by radiation. Conduction is the transfer of heat within the material itself. Most metals are good heat conductors, but wood, on the other hand, is a poor conductor and transmits heat slowly. Conduction is not an important factor in the spread of wildland fire. Convection is the transfer of heat by flow of liquids or gases. In the case of wildland fires, convection is well illustrated by the air and burned gases which rise above the fire. If the heated mixture is confined to a column, the convection current can be strong, perhaps strong enough to reach 20,000 feet or higher into the atmosphere. Convection may cause dry snags to burn rapidly. Another method of transferring heat is by radiation. The Earth, for instance, is heated from the sun by radiation through space. In wildland fires, radiation will dry fuel ahead of the fire and increase its ability to ignite. How fire behaves when only one type of fuel is involved is simple in comparison with the complex nature of a wildland fire when a variety of fuels combine with weather and topography. With careful observation of fuel, weather, and topography, we can see the influence of each of these environmental elements and reasonably predict expected wildland fire behavior. The first element we must observe is fuel. Wildland fire behavior is affected by the amount of moisture in the fuel. Dry fuel burns faster than wet fuel. Size and shape of fuel is also a contributing factor. Light fuel is quickly heated and ignited, as it is surrounded by plenty of oxygen. Fire in light fuel spreads rapidly, but burns out quickly. Heavy fuel warms slowly, and the interior becomes exposed to oxygen only after the outside has burned off. Fuel loading on an area is an obvious factor. The more fuel available, the more total heat output. Ordinarily, the greater the fuel loading readily available for burning, the more intense the fire will be. There is low fuel loading here. There is high fuel loading here. However, fuel loading may be arranged in different ways. Thus, continuity and arrangement may be more important than fuel loading itself. The fuel may be spread uniformly over the ground, or it may be patchy. There may be little fuel standing in the air above the ground, or there may be a lot of fuel above the ground in the form of snags, trees, and tall shrubs. All of these will affect the behavior of a wildland fire. Along with fuel, another important element affecting wildland fire behavior is weather. Temperature of the air influences fire. Temperature of the fuel determines how fast it will ignite and burn. There may be 50 degrees difference between fuel temperature in the sun and in the shade. Certainly one of the most important, least understood, and least predictable influences affecting wildland fire behavior is wind. Wind makes fire burn faster by increasing the supply of oxygen and by driving convection heat into new fuel. Wind can encourage combustion and the spread of fire in one direction, or it can cause rapid change in spread direction. Wind carries sparks and firebrands ahead of the main fire, starting spot fires. Wind increases evaporation from damp surfaces by carrying away moist air and replacing it with drier air. This directly affects fuel moisture. Fuel moisture influences wildland fire behavior because it affects the rate of combustion. When fuel is moist, combustion is slow because more heat is required to evaporate the moisture. As fuel becomes drier, more heat is available to heat the fuel itself. To demonstrate this point, the same type of fuel with different fuel moistures was burned in a special test chamber. The fuel in the upper chamber has a fuel moisture content of 7%. The fuel in the lower chamber has a fuel moisture content of 25%. All other conditions are equal. Note the higher combustion rate of the drier fuel in the upper chamber. Relative humidity is a factor of weather that indirectly affects wildland fire behavior. Dead fuel and the air are always exchanging moisture. Dry air, air characterized as having low relative humidity, takes moisture from the fuel. Fuel, in turn, takes moisture from the air when the relative humidity is high. Fuel moisture content changes in response to changes in the relative humidity of the surrounding air. The size of fuel will influence how quickly the fuel takes on or gives off moisture in response to a change in relative humidity. A light fuel, such as pine needles, readily shows the difference due to humidity. As fuel size increases, fuel moisture will respond slower to a change in relative humidity. All of these factors of weather, on their own or in combination, can change rapidly and will affect the behavior of a wildland fire. Topography is another environmental element to observe in order to understand wildland fire behavior. Aspect or direction in which a slope faces determines how much heating it gets from the sun. Different aspects receive sunlight at different times of day. Therefore, fuel temperature on a different aspect will change at different times throughout the day. Slope is another important influence of topography. The steeper a slope, the faster a fire burns. On a steep slope, the fuel uphill from the fire is preheated by radiation and convection and ignites easily. The position of the fire, whether near the bottom of a slope with unburned fuel above or near the top of a ridge with a change in fuel or slope ahead of the fire, is another topographic factor. The basic shape of the country in the vicinity of a fire is an important influence when a wildland fire is burning in broken topography. For example, if a canyon is narrow, heat transfer by radiation can dry adjacent fuel on the opposite slope. This can allow fire to cross the canyon. Steep canyons can have the same effect on fire as the chimney on a stove. They create a forced convection. Another effect of topography is the influence of elevation. This is shown by the earlier drying out of vegetation and fuel at lower elevations in early spring. Looking back, we have seen that the fire triangle of heat, oxygen, and fuel is necessary for combustion to occur. Once a fire starts, it spreads by transferring heat energy through conduction, convection, and radiation. The behavior of a wildland fire after it is established depends on the following environmental elements: fuel, weather, and topography, all acting together. When all three are favorable for the spread of fire, almost anything can happen. That is, anything can happen unless you, as a firefighter, intervene. One way to keep fire manageable is for you to determine fire management strategy based on your knowledge of how a wildland fire will behave in its changing environment. Is this a log, or is it a fuel to sustain a fire? Is this slope merely a hard climb, or is it a made-to-order path for fire? And is this a breathtaking view, or a stoked and ready furnace waiting for ignition? Think in terms of fire behavior and firefighter safety when dealing with a wildland fire. Remember, it is the sum of many factors that makes a wildland fire burn as it does.